Hi, and welcome to the 10 square meter workshop. Now the case of my machinist workbox is finished, it's time to make the drawers. So let's make a start. The fronts for the small drawers were cut out using a track saw. These were thickness to 12mm and will be cut into the 3 sets. I'm going to do the end joints before separating them. First job was to cut a 5mm rebate 8mm deep on all the pieces, following each cut with a piece of scrap wood to prevent tear out. Both edges of all 3 pieces were cut this way. Next, I changed to a 4mm cutter for the second rebate. I'm using a 4mm drill to set the cutter height because I don't have a gauge pin of that size. After a second trip through, the edges have the desired profile. The drawer fronts can now be separated. Using my curve clip system, I set it at 1mm over to allow for a bit of sanding and final fitting, and cut them off. I then separated the drawers using a track saw. My intention here is to make them a friction fit before making the drawers, so that very little final finishing is required. Most of the fitting will be done using my belt sander, fitted with my right angle guide. See one of my other videos for how to make one. The drawers are all within 0.5mm of final width, so not much needs to be removed. Width comes first. I want a fit that just resists the weight of the drawer front. The fence gives you a great deal of control. A belt sander will get you most of the way there, but you need hand tools and a straight edge to get this level of fit. The upper drawers were machined to dimension. The lower and centre machined to fit. Sets of parts, cut to size and sanded, were made for each drawer, ready for machining. There are 19 machining processes involved in making a drawer, and I shall be carrying out most of these in the milling machine, because this gives more accuracy and control of the process. Here are the first 2 operations on one of the side pieces that form the locking joint at the front. Note the use of a sacrificial packing piece to stop tear out. And this is the joint that results from it. Here I've just finished the next operation, the cutting of the slot for the rear. 4mm deep by 4mm wide. Next, the tongue in the back to match that slot. The end is squared at the same time, which also gives a reference for the width of cut. As you can see, it can produce nice tight joints. With that done, a basic box structure has been formed. Next step is to get the heights correct. This is largely a matter of planing the other 3 sides to match the front. With that done, we come to a critical part, the slots for the runners. These need to be reasonably precise. As I have a set of gauge blocks, I'm using these. A bit more accuracy than is really needed, but hey, why not? The top right drawer is 0.5mm out at the left hand side, so I shall adjust for that. So 10mm, oh, near enough. Cutting is pretty straightforward. A bit of rail sanding may be needed until both the runners run free. The 4 sides can then be put together and the fit tested. Last machining operation is to put the slot on all 4 pieces to hold the bottom. With the machining now all done and cleaned up, and the bottom cut to size, it's time to assemble. The drawers glued and clamped up, monitoring carefully for squareness. When dry, it looks like this. The tails at the back are deliberate. They are sanded back until the front is flush. After considerable repetition, I had a stack of drawers to fit. I'm doing all the small ones before moving on to the larger. The centre drawer was a bit different, for reasons that will become clear. The back, for instance, was quite a complex milling job. I wouldn't have wanted to do that by hand. Work holding practices don't need to be quite so robust when machining wood. I had to make at least some of the knobs, of which I need 11, before final fitting the drawers, otherwise I'd have no way of getting them back out again. This is the design I settled on, fairly simple, of brass of course. Starting point is a piece of 5/8 brass bar. Countersunk, drilled 3.3mm, which is 4mm tapping size, then tapped 4mm using my shop-made tap guide. It was then reduced to 6mm over a 7mm length to form the spigot, then reduced to 10mm for a further 7.5mm, and then 15 after that. To form the body of the knob, I ground a turning tool, rounded at this side for the indent, and with a negative turn on the other end for forming the outside. Brass is pretty tolerant of such forming tools. Here it is after the first one, and after the second, ready to be parted off now. It now looks like this. Reversed in the chuck, thanks to that spigot, I can now put a slight dome on the head. In the rough, it now looks like this. I can now hold it in a collet block for polishing. And here it is with all the machining marks polished out to a nice high gloss. And here it is unmounted. Unlike commercial brass, it has a spigot which fits into the drawer front. You will never find this commercially because it uses more brass, but it has two very useful properties. Firstly, it gives a much more stable mount into the drawer, puts less side load on the securing screw, and secondly, it gives you something to grip when machining the end. Once the drawers are sliding smoothly, the depth is set by sanding off these two legs until you get a flush fit at the front. Fitting the drawers is a matter of testing for tightness using a 0.05 gauge and finding the high spot, which is right there. And from this side, yep, it's right there. You then sand the high spot and try again. Repeat until fitted. Until eventually they meet with a minimum gap. The big drawers are made in exactly the same way as the small ones. And with the handles fitted, the woodwork is now complete. Of course, it still needs staining, polishing and lining, and there's still some hardware to do. But that's for another day. Hope to see you soon. Bye for now.